Mr. Phillips, how do I free the body diagram? Come on, babe. All right, here's how, let's break this down here. Here's how you solve a second law problem, okay? All right, you read the problem. How about that? Step 1, read the problem. The most beautiful ornate ball known to mankind weighs 38 newtons. Okay, and then I give you the mass. All right, it is on the ground and not accelerating vertically, so that tells you that the forces are balanced vertically. Some sixth grader thinks it's just normal ball pushes along with its foot, exerting a constant force of 5 newtons to the right. It slides along the ground, which exerts a frictional force of 2 newtons in the opposite direction. So we have Fc, a contact force, and then Ff, a friction force. And if you already don't know that, then it seems like you might have skipped out on like learning what the actual forces are way back in assignment 29. How quickly does it accelerate horizontally? Okay, so that tells you what we're solving for, or what we're trying to solve for. Okay, step 1, read the problem. Step 2, draw an FBD. Remember, simple shape, center mass dot, label it M, first force, F of G, pointing straight down, equal to the weight of the object given in the problem in newtons. All right, 38 newtons. Okay, but it's pointing down, so negative 38 newtons. And then next step for drawing an FBD, all other forces. What's it doing? Well, it's on a surface, okay, and it's not accelerating vertically. So that means Fn, and it's equal and opposite, so it's a positive 38 newtons. If you didn't know that, well, that's probably because you just didn't spend as much brain power as you should have on assignment 29 whenever you learned the forces, how to draw FBDs and all that. Let alone the fact that this is coming hot off the heels of an FBD practice sheet. Anyway, and then we got horizontal forces going on here. Again, F of C, okay, constant, sixth grader is pushing it along with his foot. Contact force, 5 newtons to the right. Fc, 5 newtons. And then we have friction pushing back against it with 2 newtons in the opposite direction. Shorter arrow because it's less than 5 newtons, Fc. So Ff equals negative 2 newtons. Negative because it's pointing to the left. And there you go. There's an FBD. Step 2. Step 3. F equals MA. How about that? Let's just simplify it to that. Okay, F equals MA. F net equals mass times acceleration. If you're like, well, I thought it was A equals F net over M. It doesn't matter. It's all just the same equation, just rearranged for depending on what you're solving for. But just to simplify it, just start with this. Just always make it F net equals MA, okay? And don't be confused if it's like, what is it, X, F, M, A, X, or what? Well, it depends on where's the action at. Where's the action? Where's all the action? Go where the action is. Okay, is there anything in this problem? Is there anything going on in the Y direction? No. The forces are balanced. There's no acceleration. There's nothing going on there. Okay, so we're not solving for anything in the X direction. We're not doing anything in the Y direction. All right, so we're only focusing in on the X. In fact, what are we solving for? AX. Okay, in the X direction. So if you're solving for acceleration in the X direction, you're going to use X direction forces. All right, or likewise, maybe if you're, let's say you're solving for a Y direction force, okay, if you're solving for maybe maybe there's a contact force, or no, a normal force, I don't know, something in the Y direction, then you're going to use Y direction acceleration for it. You know, so it depends on what you're solving for. If you're solving for something in the X, use all the X stuff. If you're solving for something in the Y, use the Y stuff. Right? So if you're solving for AX, okay, or trying to solve for AX, use the X direction forces. Right? What are the x direction forces? FC and FF in this problem. Right? If you know all the forces in a particular direction, okay, you could actually solve for the net force just by adding them up. Remember, F net means overall force. Net means overall. So if you have 5 newtons pushing to the right, negative 2 newtons pushing back to the left, what's the overall force acting on the object? Well, it's there's too much stuff here. It's add them up. 5 plus a negative 2. If somebody is pulling on you to the right, okay, with 5 newtons, if somebody is pulling on you to the right with 5 newtons and pulling on you to the left with negative 2 newtons, what's the overall force acting on you? It's 3 newtons. Okay, that would be F net. Okay, the net force. And then what do you do with that? Well, remember, what are we trying to solve for here? We're trying to solve for AX. So F net X equals MAX. Okay, F net is the sum of all the forces in that direction. 5 newtons. Well, scratch that, actually. Let me back up a step here. FC plus FF equals MAX. Hello? Whatever. All right, so I'm going to sub in those values now. FC is 5 newtons. FF is a negative 2 newtons equals, and we know the mass, 3.9 kilograms times AX. Okay, and you solve for AX with some simple algebras. Okay, that's all. So again, step 1. How do I clear this? Can I clear this? No. Do I hold this down? Yes! There we go. All right, step 1, read the problem. Step 2, draw an FBD. Step 3, F equals MA. And then sub in what you know and solve for what you're looking for.